Others, please turn on your cameras. Only some people have turned on their camera. What about the others? Okay, so thank you everyone. Sir, we can, if I will
Yeah,
hand over the session to you and you can start.
yeah, thank you so much, Subham. It's a great privilege for me to have interaction with you again. Maybe 2 months back, I have already given one presentation and one 3 days seminar with the Chaivasa Engineering College. So again, I have been given a chance to interact with you people. So today I will be discussing with one of the hottest topic in computer science domain is artificial intelligence and agent technology, mainly distributed AI. So possibly you are familiar with little bit of the term AI, machine learning, automation. Okay, so uh, today I will be discussing the brief about the AI, how distributed AI is applicable in different problem solutions, some motivating scenarios, and where people from mainly typically from academic institutes are working on this particular technology, uh, or where the research is going on, that I will be discussing. So my focus of discussion will be based on the work that we have been doing for the last 4 or 5 years with my PhD and MTech. Even some BTech students are also associated with that research. So that will be my discussion. And as usual, in my earlier lectures, I also used to say the same thing. Uh, it will be great if you people interact with me during the presentations. So don't wait for the till the end of the presentations. During the presentation, if you have any questions, I'll be happy to answer, because I think these are the lot of opportunities for me also to interact with the new students, to face new questions. Maybe I may have some answers. I may not give the answers for all the questions, but that will open up some new areas for me to do further work on it. So I always welcome all my students to ask question, because asking question is always good for student as well as the teacher who is taking the classes or delivering the lecture, because through asking questions, teacher can learn a lot of things from the student, lot of questions that may not come with a single mind. So when a lot of many people are attending the lecture or classes, if they ask the questions, then teacher can also learn a lot of things from their discussion. Okay, so I will request everybody to open up, use, ask question during the presentation. Don't wait till the end of the presentations, because the context may be changed. So during the presentation, you start discussing the way your teacher told, that you raise your hand or type your questions, whatever the mode, but feel free to ask without any hesitation. You ask the questions. I'll be happy to answer. At least I'll be happy to interact with you. Okay. So Shubham, I think I need to share my screen.
Yes, sir.
So you have to enable my screen sharing option.
Yes, sir.
No, it is not. It is not given. The option is not given to me.
Now, sir.
No, host disable participant screen sharing. You have to enable me to share my screen.
Okay, sir.
I think your Zoom is a paid version.
Yes, sir. Now you can share the screen.
Okay. দেখো তো দেখা যাচ্ছে কিনা?
হ্যাঁ, স্যার দেখা যাচ্ছে, অসুবিধা নেই।
The main screen.
Hmm.
The main screen is visible.
Yes, sir. It is visible.
Yeah. So my main topic was distributed AI and agent technology, mostly focused on the computer science and how automation takes place in distributed environment. So we have a very small research lab in the Department of Computer Science and Engineering, namely as multi-agent and distributed computing lab. Most of the people used to work here either in the area of agent technology, agent and multi-agent technology, or some people work on social network analysis and big data. So these are the areas where most of my students used to work. So today my topic will be AI and agent technology, artificial intelligence and agent technology. So before I discuss the main content of the topic, I will come up with a very brief motivational example. Then I will be going to the detail of it. So we are in 2020, and what we are expecting in 2021, let us have a scenario. Suppose there is a one person named as Proful. Name as Proful. He is moving, driving his car, and he has a meeting with his boss. So while driving his car to attend the meeting with his boss, he is saying, I have a meeting with my boss and I am late. So his mindset is, I am already late and I am going for the meeting. I have a meeting with my boss. Suddenly, he received a phone call. Suddenly, he received a phone call from an unknown number. The phone call says, your wife had an accident and she is admitted at some hospital in Powai. So while driving his car to go to his office, to go to his boss for attending the meeting, suddenly he received a phone call from an unknown number, and it says that your wife had an accident. She is admitted at some hospital. It is an unknown hospital. I mean, the known hospital name is not known, but the hospital is located in a Powai because the accident took place in Powai. So what it did, Proful think that I should inform my agent to reschedule the meeting. So just like think, an agent is somebody who does work on behalf of somebody. You may have a travel agent, you may have LIC agent, you may have a railway ticket agent for whom you can ask for booking the ticket. Okay, so Proful has an agent. Of course, here the agent is not a person. Here the agent is a software entity, software program. So I should inform my agent to reschedule the meeting. Okay, Proful is thinking that I should inform my agent to reschedule the meeting. Proful agents negotiate with boss's agent and reschedule the meeting to tomorrow. So think of the scenario that as Proful has an agent, in the same way, his boss has also an agent who knows every information of their owner. For example, Proful's agent knows what is his requirement, what is his preferred time, what is his engagement for tomorrow, etc., etc. In the same way, the agent of boss also knows what is his engagement for tomorrow, what are the free time, etc., etc. So both the agent, the boss agent and the Proful's agent, started negotiating by some kind of message passing that Praful's wife met with an accident. So today he cannot attend the meeting. Can we schedule the meeting tomorrow? So depending on the availability, bosses doesn't reply and they negotiate that tomorrow could be the meeting. And accordingly, Praful's agents reply to Praful that the meeting is rescheduled to tomorrow. Your meeting is rescheduled to tomorrow at 5 p.m. Okay. The next thing, it comes to Praful's mind that still I don't know where is she admitted in Powai. I know from an unknown phone number that my wife met with an accident, but I still don't know where she is admitted in Powai. So I should again use my agent to know where she is admitted. So Praful requests again his agent that please get this information where my wife is admitted. Here you keep it in mind that Praful's agent knows what is the name of Praful's wife or other details. So Praful's agent started negotiating with some middle agent. This is a middle agent to find out some hospital in Powai. It starts negotiating with some kind of middle agent which are located in different hospitals in Powai. So Praful agents contact a middle agent to find out some hospital in Powai having a recently admitted patient, or you can say accidental patient, named as Geeta. So accordingly, his agent replied, your wife is admitted at New Powai Hospital, ward number 9. So that is the reply of Praful's agent. That your wife is admitted at New Powai Hospital, ward number 9. Next, Praful started driving his car to the New Powai Hospital. So think of a situation that here many of the actions that needs to be performed by the owner himself, but on behalf of the owner, his agent is doing some of the work. So what are the different types of automations here? You can say make information on the web from more machine friendly approach. That means whatever the information that you are keeping in the machine, it should be machine understandable form. That is called semantic web or web of data or metadata. Second, interoperability. The agent who is working, it is trying to interact with the other agent. So here in this scenario, Praful's agents interact with the boss's agent. Praful agents interact with the agents of different hospital. All right. So whatever form of informations either the hospital keeps or whatever the form of informations this boss's agent keeps, they are in an interoperable form. That means each agent from the different domain can discuss, talk each other. Second thing, here not only agent to agent interactions, but also agent to human being. So here agent is nothing but is a machine or a program or a software program. So we are not confined only agent to agent interaction, rather we are talking about agent to human being discussion. So agent to agent communication and agent to human being communication. So that's why the data should be in a machine friendly form. So this is one of the motivating scenario with which I will start today's discussion. So these are the brief content of the today's discussion. I will start from the very early how the computer system evolved and what is the modern trend of computing and how the programming paradigm with the computer science people, we are very much familiar with the computer programming. Started with the first semester or second semester, we have an introduction to computing. So how the programming paradigm shifts from programming to automation, that we will be discussing. Then we will take some kind of research challenge, some real life applications. So if you see, there are 5 trends of modern computing. The first trend is ubiquity. Second trend is interconnection. Third is intelligence. Fourth is delegation. And the fifth is human orientation. So these are the 5 trends of any modern computing system. I will be discussing this thing, then how computer system evolves, that I will be covering. So ubiquity means it's a kind of omnipresent. The computer system is present everywhere. Whether you purchase a cell phone, whether you purchase a bike, whether you purchase a car, even today's the smallest, cheapest car, the Nano is also equipped with a microprocessor controller, which controls the fuel and the air mixture from that ratio. You may have AC, you may have fridge, washing machine, micro oven, everything is connected with some kind of processor.
Sir, Moore's law क्या है? Sir, what is Moore's law?
Moore's law says that the cost of computing power will be double. Cost of computing power will be double in every 18 months. In other way, we can say, whatever the computing power today you can purchase with a certain cost, with the same cost, you can purchase a double computing power just in 18 months, after 18 months. So Moore's law says cost of processing power decreases dramatically. Computers use everywhere. So every 18 months, in every 18 months, the cost of computing power is getting doubled with the same price. Okay, so this is one thing. The second thing, the size of the processors, the size of the computing devices is getting very small. So everywhere it can be equipped. Everywhere it can be embedded. Whether it is a mobile phone, whether it is a camera, whether it is a printer, everywhere. Everywhere it is connected. So that's why it is an ubiquity, or sometimes it is called omnipresent, present everywhere. And this is possible because of the cost of computing processing power is less. You just see, when we purchased computer, my first computer was in 2000, and that was 533 Celeron processor. 533 Celeron processor, 10 GB hard disk, 64 MB RAM, and its cost was 35,000. Now today, if you spend 35,000, you can imagine the processing power that you will get. It is some multiple of that 533 megahertz Celeron processor. Today, if you purchase a hard disk, minimum it should be of 500 GB or 1 TB. So think of 500 GB or 1 TB is how much it's multiple of 10 GB hard disk. That is more slow. Okay. Interconnection. Today, any computer is no more a standalone machine. It is connected with some multiple computer. Whenever you think of a computer system, whether it is a laptop or desktop or anything, any computing devices, even if you have a computing devices, your TV is also connected with a processor, and you are trying to connect it with your mobile phone. Some IoT devices. People are thinking of smart home, where all the gadgets will be connected with some kind of network. Okay, so today computer no more a standalone system. It is connected with multiple devices through some kind of network. Today people are very much habituated with doing their internet banking, purchasing everything through mobile phone. They don't go to the bank or ATM. The new generation people, the youth people don't go to the bank or even ATM. You have some kind of pay, Google Pay, Amazon Pay, Phone Pay. Okay, and you feel that everything is in my mobile phone. Just I need to purchase, I will pay it from my this. I'll pay it from that. You have an account in Amazon, or you have an account in Flipkart, you have an account in Zomato, Swiggy, and you are doing all these things, just having a small devices. And that small devices is connected with some kind of network. That network gives you all these services. Booking your food from Zomato, Swiggy, doing some kind of purchase from Amazon, Flipkart, doing some other banking, controlling your fridge, TV, just having a small device. So today computer is interconnected. Along with the above two, there is one more thing that is coming is intelligence or artificial intelligence. The complex, so what is AI? This is the capability of computer system. This is the capability of computer system to perform complicated tasks or complex tasks. It is the capability of computer system to perform complicated or complex tasks. Many of the organizations are keeping small devices for biometric attendance. So very small devices that can do all sort of image processing to detect whether the person who is putting his thumb is the right person or not. So the AI algorithms are running. It can easily detect whether it is the correct persons or not. It is the capability of performing complex tasks like human being. Today, we are thinking of a driverless car. We think that the way people should drive the car, we are expecting a computer system will run the car in the same way. Next is delegation.
Sir,
Bolo? Yeah, please.
how would we get to know? How would we get to know what are the limitations of AI, sir? Where AI can't perform like humans.
So that you cannot say limitations. Maybe we, the people, are not capable of designing the algorithm. See, AI, AI is not a something. It is, beyond imagination. It has been designed by the people only. It has been designed by the researcher only. Okay. So today, whatever AI-based job you are thinking or you are saying, these are designed by the people like you, me. Okay. So if a computer cannot do a particular task, it may be because that we are unable to design such algorithm that can solve those complicated tasks. So that you cannot say it is an drawback of computer system, or it is a bottleneck of AI. Why you can say it is a bottleneck of AI? You can say that some people are getting addicted, maybe through some game. In this, in this Durga Puja, I have seen, it was very astonishing for me. I went to the Durga Mandap, which is very close to our, in our locality, in our Pada. So I have seen a lot of people of the age is around 12, 13 years. They are sitting together, 4 or 5 people sitting together, and they all are busy with the mobile. So I asked my son what they're doing. So actually, my son is a friend of those people. They used to do some kind of have their sports in the evening in the playground. So I asked my son what they are doing. So my son replied, "Papa, they are busy with doing some kind of network game. So all are competed with each other." So what Durga Puja is going on? They are not. They were present in the Puja Mandap, but they were not involved in the puja, but rather they were involved with the mobile phone. What is happening outside, what is happening in the environment, they were unaware about the fact. So I don't know. So this may be one of the drawback for computer system is coming to the new generation. That you can say it's a drawback, but which still cannot solve. That you cannot say it's a drawback, right?
Okay.
Next is your delegation. So delegation is something like the task which people should do, which I should do. Instead of doing by myself, I am delegating that task to somebody else, some system, which will perform the task on my behalf. An example is autopilot or a driverless car. A driver is supposed to drive the car. A driver is supposed to drive the car. But instead of that, what is happening? We are replacing some computer system who will drive the car for me. Autopilot. The pilot is replaced by a computer system. So we are giving control to computers even in safety critical tasks. So there is a term called safety critical task, where if the task is not performed properly, there is a risk of losing life. There is a risk of losing a monetary loss. So these are called safety critical tasks. So today we are habituated to give control to the computer to this type of safety critical tasks. Next is your human orientation. Today computer is working just like a human being. The example, one of the example is, if you purchase a today's mobile phone, the modern mobile phone, you don't need to interact with the keypad. It can detect like your voice. You say something, it can understand what you want to say. So the behavior of the computer system is like a human being, as if it is working like a human being. So if you see the evolution of computer system, this is the two figure. One figure is the earlier computer and this is the modern computer. The earlier computer was a standalone machine. It has some kind of terminal where you have to write something and you will get some answer. But today's computer is, of course, it has a very good interface. It has a very good visualizations, connections, interconnections with the other devices, maybe Bluetooth, Wi-Fi, network, internet. Okay, so 100 millions of people connected by email once seemed to be a science fiction. I mean, even 20 years back, it was a science fiction that people will be talking like anything. I mean, today, people are, we used to talk like in a WhatsApp or email, it's just like I'm talking with somebody sitting in front of me. So today, talking over WhatsApp or email is just like sitting side by side. So 20 years back, it was just a science fiction. If somebody says that connecting hundreds of people together over a WhatsApp group or over an email group, or interacting with the email or WhatsApp with the people sitting in USA or New York or somewhere else, was a science fiction. Similarly, so today whatever we are discussing, the motivational example that I have started at the beginning, looks like a science fiction. But we are very sure that once it will be true. So, programming progression. Programming has progressed through these steps. In the very early days, it was a machine code. The first programming was machine code. You have to write the entire program in some kind of 0-1 programming, like a binary code. And before writing the program, you have to think about the system for which you are writing the code. It is not like today's computer system that you are writing a program in Java or Python in one machine, and that program can be taken in pen drive and you can execute to some other machine. It was not like that. So it was highly dependent on the computer. So before writing the machine code for a particular machine, to execute a particular machine, in a particular machine, you have to think the architecture, the hardware architecture of this machine. You have to understand the hardware architecture of that machine. Based on that, you can write the code. Then only the code will be executed by that machine. And once you write the code, that code cannot be used for executing some other hardware architecture machine. So after machine code, the next is assembly language. So assembly language is somewhere abstract then of machine code, where the 0101, these symbols has been replaced by some opcode, and or multiplication, division, exchange, store. So you have some kind of code for each of these operations. And that programming language, that assembly language, is also machine dependent. So before writing any assembly language code, you have to understand for which machine you are writing the code. So depending on that machine, you have to write the code, because the opcode, the operational code for different hardware will be different. So before writing the code for a particular machine, you have to understand what architecture this machine is having. Accordingly, you have to use that opcode. Okay, next comes the first machine independent programming language. The concept of machine independent programming language. That programming language is independent of machine. That means if you write a program for one machine, you can easily transfer or copy this program and can execute to some other program, to some other machine. That is called machine independent programming language. And that language gives you the flavor of some kind of natural language expression. So you are writing the program just like as if you are writing the program for your in English language, English kind of language. After the machine independent programming language, the next evaluation is subroutine, then procedure and functions. So subroutine based program is COBOL, Fortran, where just like the functions, you can create a subroutine for a specific purpose, and that subroutine can be called from the main function several times. Then the evaluations is procedures and functions. Procedures and functions. Next, it comes abstract data type. You can create your own data type. For example, you can create stack, queue, array, whatever. You can create your own data types. Hello? Hi, কিছু বলছো? Hello? Any questions? So next is your abstract data type, where you can create your own data structure for writing your own program. For example, you are going to write a program, and that program needs some kind of data structure which is not predefined in your programming language or compiler. So at your own requirement, you are creating a data structure. It is called abstract data type. After that, it comes object-oriented programming, C++, Java. These are object-oriented programming, where each and every concept is treated as an object. And whatever we treat as there are different properties for object, then class inheritance, polymorphism, these features are there. So when you write a program in object orientation, you can use this concept. The next layer is the agent. where the abstraction is more higher than of object. So how it comes? It comes that a programmer or an user does not need to repeatedly say how to do the thing, just to say what to do. Proful says its agent that please reschedule the meeting. Now agent knows how to do it, how to interact with the boss's agent. Proful says that I have to go to see my wife, but I don't know where she is admitted. The agent takes care of it. She knows, that agent knows that where to get these informations. So agent is something like more abstraction than object, where you don't need to say repeatedly how to do. You just say what to do. It is the capability of the agent to do the task at his own. And that comes to the new concept that is called delegation and intelligence. Delegation and intelligence imply the need to build computer system that can effectively work on our behalf, that can act effectively on our behalf. So we want to build computer system. We want to build such a computer system that will work on behalf of us, that will work on behalf of us. So think of the scenario that you want to, in this winter vacation, you want to go to some holiday tour. For you have the vacation from 25th December to 30th December. And you want to go with your family. These are the members, etc., etc. And you want to go to Simla. But you are so busy persons that you don't have the time to book your ticket, flight ticket or train ticket, hotel booking, sightseeing booking. You don't have that much of time. So what you did, you contact a travel agent. You give your requirement that I have 5 members in my family. These are my budget. I have the plan to go on 25th and return by 30th. So as per your requirement, this travel agent will try to find out the best match for you. The flight or the train, and reaching to Simla, then hotel booking, then local site booking. Maybe you may be staying 2-3 places. So accordingly, the travel agent will book different hotels. So all these things will be done by the travel agent. You don't need to do all these things. So you are delegating your task. You are delegating your task to an human agent who will do the work on behalf of you. So that implies independently. The ability of computer system to act independently. It is not dependent on you. Just you give your requirement, the agent will do everything for you. That's called independently. Next, the ability of computer system to act in a way that represents our best interest. So for this particular travel, we have some requirement, we have some preferences, maybe budget preferences, maybe hotel preferences, maybe the train preferences. So all these requirements have been taken by the travel agent, and accordingly, it will try to satisfy all these things. So it is the ability of the agent, it is the ability of the computer system to act in a way that represents our best interest while interacting with other human beings. So computer science expand. So computer science expand. It is no more a standalone dumb machine. All these trends have led to the emergence of new field of computer science called multi-agent system. A new field in computer system that is called multi-agent system. What is that? So very brief definition of agent. Very brief definition of agent. An agent is a computer system. An agent is a computer system that is capable of independent action on behalf of its user or owner. An agent is a computer system that is capable of independent action on behalf of its user or owner. Agent is capable of independent action. Agent action is purposeful. Whatever the agent is doing, it is doing for some purpose. That means it has something, some goal in his mind. To achieve that goal, agent do the work. Agent is capable of independent action, and agent action is purposeful for achieving some goal. Agents, one more definition. An agent is anything that can perceive its environment. That means it can sense the environment. An agent is anything that can sense its environment. It can sense the environment and act upon that environment through its effector. So sensing the environment and acting upon the environment. An agent is anything that can perceive its environment through its sensor and act upon that environment through its effector. And what is multi-agent system? A multi-agent system is one that consists of a number of agents which interact with one another. So there are a lot of tasks where a single agent is not sufficient to do the work. There you need a group of agents. So a group of agents collectively interact with each other to achieve some or one goal. That is called multi-agent system. Agent autonomy. A system is autonomous. So whenever we say agent, at the same time, the question comes, what is autonomy, or the autonomy, autonomous or autonomy comes, these two terms come in the picture. A system is autonomous if it requires little help from the human user. If it requires little help from the human user. That means user does not need to say everything to the agent. If we don't have to tell what to do step by step, if it can choose its own goal and the way to achieve it, it can choose its own goal and the way to achieve it. If its behavior is determined by its own experience, the agent can learn from its own experience. As a user, we don't need to know the internal working principle of agent. So if these 5 qualities are there, we will say a system is an autonomous system. And we believe that an agent should be designed to satisfy all these four criteria. Next is intelligent agent. Some of the desirable properties that an agent should have, then we will say this agent is an intelligent agent. Reactive, proactiveness, and social ability. Intelligent agents should respond in a timely fashion to change they perceive in their environment. So it is a reactive agent. Okay. So reactive agent is based on the current requirement. Whatever it sends from the environment, accordingly it will perform on the environment. For example, a thermostat. An example is thermostat. A thermostat in AC. A thermostat in a heater. It has been fixed to a certain temperature. If it goes beyond it, the heater will start. If it goes above it, then the cooler will start. So it is a reactive agent. Proactive agent, when an agent will have some goal in his mind and it will perform the task to achieve that particular goal, then we will say the proactive agent. So intelligent agent can take the initiative to meet their design objective and they exhibit goal directed behavior. The third property is intelligent agents can interact with other agents to satisfy their design objective. So social ability is a kind of society. Just like in the hostel, people used to stay and you may have a lot of friends. So earlier, before taking admission in Cyber Engineering College, you may not have the friends in Cyber Engineering College. The moment you take admission in Cyber Engineering College, you have been put in the hostel, and during the stay in the hostel, you may have a lot of friends, mates. So it is the capability of you to form a society, ability to interact with the other people. That is called social ability. So intelligent agents can interact with other agents to satisfy their design objectives. Sure. If an agent has these three properties, reactivity, proactivity, and social ability, then we will say this agent is an intelligent agent. So an agent's autonomy. Here is an autonomous device, is an example of thermostat situated in an environment and it has some purpose. But we cannot say it is an intelligent agent because it has a reactive property. It has a reactive property, but it doesn't have the proactive property or social ability. It is a single agent, it doesn't have the social ability. So if a purely reactive agents, you just see the two. If the heater off, make the heater off. If E temperature is okay, make the heater on, else. So these are the two parameters that are kept. So it is a purely reactive agent. What is an environment? The environment is the entity in which an agent is situated. An environment is the entity in which the agent is situated. So it is that this environment that an agent senses and acts. Okay, so whenever we will design an agent, that agent will be in some particular environment, maybe in some physical environment, maybe in some computational environment, where it can sense through some sensor. It may be some hardware sensor with which it can sense the environment. It may have some kind of software sensor through which it can sense the environment, or it can sense the other agent. And accordingly, it will perform certain tasks, and that will change the environment. Okay, so that's why the example is an agent can sense through its sensor, or sometimes it is called perception, percepts. And based on the perception, it does some kind of computations, and through its effectors, it performs action on the environment that change the environment. Therefore, do you have any questions? Any questions?
If anyone has any question, please ask, sir. Anyone?
Okay. Next is your classification of environment. So there can be different types of environment. So as I said, we are going to design some agent. Now, whenever we think of the agent design, that agent must be working on some particular environment where it will sense something, and based on the sensing or perception, it will react, and it will react on the environment itself. That will change the environment from one state to another state. So while doing this thing, while designing the agent architecture, we have to think what is the actual environment is. What are the things it can sense? How often it will sense? Whether this sensing and perception and affecting or doing some changes on the environment is a continuous process. Is it a dynamic process or static process? So all these things that comes while you think of the agent design, you have to take into consideration your environment. So first is accessible versus inaccessible. If the agent can access the entire environment, then we will say it is an accessible environment. If the agent cannot access the entire environment, then we will say it is an inaccessible environment. So of course, designing an agent for an accessible environment is easy in comparison with the inaccessible environment, because in an inaccessible environment, you won't get the entire scenario of the environment. Next is deterministic versus non-deterministic. For every actions performed by the agent on the environment, it will lead to some other state. Now, if agent can determine that which state it will lead, then we will say it is a deterministic. Otherwise, it is a non-deterministic environment. Again, working on the deterministic environment is easy in comparison with the non-deterministic environment. But because for deterministic environment, you know that it will guarantee, it will give you guarantee to reach to that state. Next step. What next step you will be reaching? Static versus dynamic. Does the environment changes during the execution of the agent? So if the environment changes during the execution, then you will say it is a dynamic environment. Otherwise, it is a static environment. Next, you have episodic, non-episodic. If agent's decision and the action, they are all separate entity. One perception, then action. Perception and action. If all these are a separate episode, then we will call this an episodic environment. Otherwise, it is a non-episodic environment. Rather, it is a continuous environment. Similarly, you have discrete continuous and you have open environment. So open environment where it is an inaccessible, non-deterministic and dynamic and continuous environment. So for all this complexity, it reaches to your dynamic environment. It's a dynamic environment. So I'm not going to this detail of the agent architecture or abstract. I mean, before going to that, I would Shubham, I would like to know. Shubham, are you there? Hello.
All the participants are requested if they have any question, please ask sir.
Hey Shubham,
Sir, bolo.
these students are which semester?
In third semester and fifth semester, sir.
Okay, have they gone to this automata and algorithm?
Yes, sir. Fifth semester students have already taught automata subject.
Okay. So, if you student তো কমেই যাচ্ছে তোমার
হ্যাঁ স্যার ওই একটু প্রবলেম আছে এই লিংকের আমাদের নেটের একটু ইস্যু হয় রিমোট প্লেসের জন্য
so actually if they know automata, then I should go this abstract agent architecture. Otherwise, there is no use of discussing this thing because this type of symbol and state change they cannot understand. Anyway, briefly, I am trying to go.
Okay, sir.
Assume a discrete finite set of environment states, E, capital E, which compose of E1, E2, E3, dot, dot. So approximation of continuous state space. Assume action, different types of action that agent can perform on the environment is AC. These are alpha 1, alpha 2, alpha 3, dot, 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 dot. Now, what is the idea? Idea is environment starts at some state and agent chooses action in each state which leads to a new state. So an environment is in a particular state. It then perceives the environment. Then it performs some actions from alpha 1, alpha 2, alpha 3, dot, dot, any one of the alpha. After performing that action, it will reach you to some other state of the environment. So if you if you see the combinations E1, sorry, E0, initially the agent was in the environment E0, then it performs alpha naught. It takes it to E1 environment. In E1 environment, it performs alpha 1, it should be alpha 1 action. It reaches you to E2 environment. In E2 environment, it performs alpha 2, it takes you to E3 environment. So in this way it goes on. This sequence of interleaved environment, state and action is called a run. So run is a sequence of interleaved environment, states and action. Define R, which is a set of E, the set of all such finite sequence. So there can be different such run, because there can be different such combination as we have a different set of state environment, set of environment and different set of agent action. So abstract agent architecture, it transforms, an agent is a transformation function. So in a more abstract way, we can say an agent is a transformation function pi, which reaches RAC to a new environment set. So this function maps each run ending with an agent action to the set of possible resulting state. Depends on history of previous state. And during this, there can be different types of uncertainty and non-determinism. So you need to model the uncertainty and non-determinism as well. Okay, I'm not going all these things. So there are different types of applications in multi-agent system. So multi-agent system can be used to model various applications, whether it is in computer science or non-computer science. It starts with transportation and logistics, workflow, business process management, distributed sensing or sensor network. Information retrieval and management, electronic e-commerce, human-computer interface, virtual environment, social simulations. So there are many more applications where agent can be used. So I'm not, okay. So, now, now you may have a questions. Then what is agent and what is AI or distributed AI? While we say AI, artificial intelligence, it is something like it is the capability of performing complex tasks. Okay, it is a capability of computer system to perform some complicated task. So you have some kind of databases, you may have some kind of knowledge bases, and you want to extract some meaningful information of that. You want to build some kind of expert system for maybe some medical domain. You want to build a biometric attendance system. So these are the traditional AI-based system. When we say AI is something like you have some kind of knowledge base, you have some kind of rule base. Of course, it can sense the environment and it will perform some task. But when we say agents more like on distributed AI. Agents means it is not the single agent, rather a group of agents working together. So when we say group of agents, that imply that these agents are not situated in only one single machine. They may be distributed across the globe, across the network. Okay, a group of agents, capability of having the AI or AI capability distributed across the network. Distributed across the network. Okay, so each of these agents are sensing their own environment. They are situated in different environment, but they have a connection. They have some kind of connectivity through some kind of message passing. So in bottom of agent, there must be AI. So collection of some such AI capable agent, we will see a multi-agent system. So the agents field is more concerned with combining this component. This may mean we have to solve all problem of AI, but agents can also build without any AI. You may have AI, you may not have AI, where you have a lot of interactive component. It has, when we talk about simple AI, we may not, or we may ignore the concept of social interaction. But when we call about agent, the moment we will say agent, it must have a social capability, society formation. So there are two challenges while designing the agent-based system. One is micro problem, another is macro problem. The micro problem is the agent design, and the macro problem is the society design. Agent design, how do we build agents that are capable of independent autonomous action in order to successfully carry out the task that we delegate to them? So when we say agent design, we consider the design of an agent as an individual, a single agent. So how do we build agents that are capable of independent autonomous action in order to successfully carry out the task that we delegate to them? Next, you have society design. How do we build agents that are capable of interacting? So here you see, the moment we go from agent design to society design, the first thing that will coming in the picture is the interaction. So when we talk about the society design, the first thing that will be in a picture is interaction. Cooperating, coordinating, negotiating with other agents in order to successfully carry out the task that we delegate to them. How do we build agents that are capable of interacting interaction means cooperation. People are cooperating with each other to stay in the same room. In the hostel, it's a very common thing for cooperation. Coordination. A group of people in a football match on a team. So they need a coordination to have a successful in the match. You need to have a very good coordination mechanism. Negotiation. Sometimes you need to negotiate. Maybe you are trying to purchase something in an auction. You need to negotiate with the other people. So in general, all this comes under the picture of interacting with other agents in order to successfully carry out the task that we delegate to them. So if you see the society design in a diagrammatic form, the overall is interaction. Overall design is interaction. Under the interaction, you have coordination. Coordination can be of competition and cooperation. With cooperations, you can have collaborations. But for all these cases, whether you go for collaboration, cooperation, competition, coordination, you need communication. So the moment we say agent-based system, we must have to think about the society or social, which we don't consider in simple AI. This is one thing. The second thing is, the moment we say society or social or agent are social, it must have some kind of communication medium. That means one agent can communicate with the other agent. To successfully interact, they will require the ability to cooperate, coordinate, and negotiate with each other, much as people do. So it is something like the way we interact with each other for cooperation, coordination, and negotiation in the same way we are trying to be done by the agent system. So that means we want the way we interact in the society in the same way agent will interact with other agents. In the same way, the agent will interact with the other agent. So there is a famous model for agent designing. It's called Belief, Desire, Intention model, VDI. Belief, desire, and intention model. So let us take an example. A person's leaving for office in the morning and says, the weather is cloudy. The weather is cloudy. So I should take my umbrella with me. The weather is cloudy. So I should take my umbrella with me. So there are three things that are associated with this thinking. What are the three things? The first thing is the belief. The second thing is the desire. And the third thing is the intention. What is belief? From the past experience, the person believes that if the weather is cloudy, there is a possibility of rain. If the weather is cloudy, then there is a possibility of rain. Desire. What is the desire of the person? The desire is he doesn't want to get wet. That is his desire. So what is the intention? Either to take umbrella or some other means. So he is choosing the intention. He is choosing the take the umbrella. So belief, desire, and intention model. So this belief, desire, intention model come when we talk about the idea of this agent design or agent. Intention, in order to speech, intention refers to action or to states of mind. Here we consider the latter. We make reasonable attempts to fulfill the intention once we form them, but they may change if circumstances do. An agent intends to do action alpha if and only if it has the persistent goal to have brought about a state where it believed that it would about to do that. So what was the belief? If there is a cloudy weather, then there is a possibility of rain. If the weather is cloudy, then there is a possibility of rain. That is the belief. Desire is, I don't want to get wet. What is the intention? There can be possible intention is taking umbrella, taking raincoat, going by car, etc., etc. Out of this, he chooses one of them, taking umbrella. So while talking belief, desire, intention, that means the agent is perceiving the environment. It senses the environment through its sensor. What is the sense? It is sensing that the weather is cloudy. That is his sense, sensing the environment. What is the goal? Goal is actually the desire. I don't want to get wet. Intention, there are 3, 4. Out of that, one he is choosing as an action. Taking umbrella with him. It is the basic preferences of the agent. Okay. So if you see the BDI architecture looks like this. It senses the environment through sensor input. Then you have some kind of belief. Belief may be device. Belief is the knowledge base. So that person has in the mind that if there is a cloudy weather, then there is a possibility of rain. So this is the belief base. And this belief base may be updated. This belief base may be updated over the experience. This belief base is getting updated over the experience. Next, generate options. From there, it finds a desire. What is he wants to do? He don't want to get wet. From there, he chooses what are the possible things that he can do. Taking umbrella, going by car, taking raincoat, etc., etc. That is comes the intention, and based on that, it performs some operations, taking the umbrella with him. So that is the action output. Okay, so in a formal model, it is shown like this. So let believe B belongs to BEL, desire D belongs to DES, I is a with all sets describe the belief, desire, intention of the agents. The perception PAR, PER, and action AC as before. Plan a set of all plans for now and sequence of actions. So belief revisions. Your belief, as I said, the belief will be revised over the experience. So belief and the perception. Perception is perceiving the environment. So earlier belief base, adding with the perception, it will give you a new belief base. Earlier belief base with perception, it reaches you to new belief base. Belief, then set of intention that will take you desire. Then belief, desire, intention. Bolo? Hello? Hello? Anything you want to say, Shivam? Shivam, do you want to ask anything?
No, sir.
Huh?
No, sir.
Okay. So this is my belief. Generating options, then filtering and select the options filter. Then what he wants to do, the plan. So it is something like the formalizations of the idea of how the agent will work. Now, when we talk about multi-agent system, in multi-agent system, we address questions such as, how can cooperation emerge in societies of self-interested agents? How cooperation emerge in societies of self-interested agents? What kind of language and agents use to communicate with one another? Now, while interacting, there may be a lot of conflict. So how you design the algorithms to resolve those conflicts? So, as I said earlier, when you go from one agent to multi-agent system, there are a lot of issues will be coming to the picture, just like the human society. Coordination, cooperation, negotiation. And for each of these cases, based on the situation, you have to have some algorithm to resolve this thing. So one of the example where people are working today, some theoretical idea. So today I will be discussing this thing also. It's called constraint. Okay. So whenever we do something in our society or in everyday's life, we have certain constraint. You people are staying in the hostel. You have a constraint of money. You cannot spend as much as possible. You have a semester exam the end of December. You have a constraint of time. You don't have enough time. So this is called constraint. So when an agent interacts or when an agent works in an environment, it has a lot of constraint that it needs to face. So these are usually perceived as elements that limit solution to the problem we face. So from a computational point of view, they reduce the space of possible solutions. They reduce the space of possible solutions. Time is a constraint. As a student, money is a constraint. You have to stay with a limited budget in the hostel. You may be staying in Chaibasa Engineering College or maybe in the hostel of the Chaibasa Engineering. There are some constraints in the campus. You don't have shopping complex. Your market is far away from your campus. So these are the constraints. So any moment if you require any kind of some essentials item, you cannot go. These are the constraints. Okay. So one of the paradigm of research from the computational or algorithmic point of view in a multi-agent environment is constraint processing. So it is in computer science, it is in algorithms, it is in management science, it is in mechanical, it is in electrical, in everywhere it is constraint processing or constraint programming is there. Okay, so one of the very popular example of constraint is meeting scheduling problem. Okay, it's a meeting scheduling problem. So there are many people who wants to sit for a meeting. Now they have a different types of preferences. Different types of preferences of the time. One is the preferences, the other is the availability. Maybe one person may have 2 meetings, 3 meetings. So based on the preferences and availability of the member of the meeting, the objective is to schedule a meeting such that 2 meetings of the same person should not be at the same time. 2 meetings of the same person should not be at the same time. Meetings should not start before the availability. Meetings should give the individual's preferences as much as possible. So this is a distributed constraint optimization problem. So here today, in the situation of this pandemic, COVID-19, we are very much familiar with doing all these kinds of meeting over online. So normally we don't go to the class. We interact with the student through online mode. We sit with the people of my colleagues in an online mode. So here, availability and the preferences is one of the important thing. Some people don't want to attend meeting in the early morning. Some people don't want to attend the meeting in the evening. Okay, so one is the availability, another is the preferences. So based on all these things, you have to schedule a meeting. So this meeting scheduling problem is called distributed constraint optimization problem. So how will you formally define this thing? So formally it is defined like this. A constraint network N is formally defined as a tuple. Tuple, those who are familiar with the automata, you can understand what is the meaning of tuple. XDC, where X is a set of discrete variables, x1, x2, x3, ... xn. D is a set of domain values. So what is the domain values? X1 is a variable, it can choose any values from D1 to Dn. X2 is another variable, it can also choose any values from D1 to Dn. X3 is another variable which can also choose any values from D1 to Dn, like this way. It's a set of variables domains which enumerate all possible values corresponding to variable. Next is constraint. What is constraint? It's a set of constraints where a constraint Ci is defined on a subset of variables Si which comprise the scope of the constraint. For example, x1 cannot take particular value. X3 cannot take a particular value from this. So these are some kind of constraint. The girls' hostel is closed at 10 in the evening. So they cannot go for study or in the library after 10. So that is a constraint for them. But the boys' hostel is open 24 hours. Anybody can go outside any moment of time. So that is a constraint for the girls' student. So there are two types of constraint. One is the hard constraint, another is soft constraint. The example as I have given, the two meetings of the same person cannot be at the same time. That is hard constraint. Two persons, two meetings cannot take place at the same time. I want all the members of the committee should be present during the meeting. Okay, so availability of the persons should be the duration of the meeting. So these are hard constraints. What is soft constraint? There are some preferences of the member. Somebody wants to say that please don't put the meeting in the morning. But it is his preferences, not the constraint. So this can be treated as a soft constraint. He can attend the meeting in the morning, but his preference is not in the morning. There are some people who after the lunch used to take a nap. So they don't used to take classes after the lunch. So that is a soft constraint, but if there is an urgency, they can attend it. So this is called soft constraint. Okay. Now, based on this, there can be two variations of the same problem. One is called constraint satisfaction problem, another is called constraint optimization problem. In constraint satisfaction problem, in any case, you cannot violate a constraint. So find an assignment of all these variables such that the constraint should be satisfied. What is constraint optimization problem? If you violate the constraint, your value will be, your payoff value will be decreased. So your optimization value will be decreased, and your objective is to increase the value. So if you violate a constraint, your payoff value will be decreased. So this constant satisfaction problem and constant optimization problem that leads to distributed constant satisfaction problem and distributed constant optimization problem. And these are, both of them are computationally hard problem, NP complete problem or NP hard problem. Now, while we talk about the DCOP, distributed constant optimization problem, along with XDC, the variable, the domain, and the constraint, there is one more association, is called agent. So for each variable, there is an agent. So agent A1 is responsible to choose the value of X1. Agent A2 is responsible for choosing the value of X2. Agent A3 is responsible for choosing the value of X3. Similarly, agent AK is responsible for choosing the value of XK. D is the domain and C is the constraint. So we assume that agents are fully cooperative. That means they can cooperate with each other, they can interact with each other, they can have message passing. So some of the real applications of DCOP problem is a meeting scheduling problem. Other example can be sensor network, robotics, etc. Like target tracking. So take a very popular example, a popular problem, or sometimes it is called as a classical problem, graph coloring problem. Those who have already gone through this algorithms, they know what is graph coloring problem. So graph coloring problem, suppose there are 4 nodes. There are 4 nodes. Node 1, node 2, node 3, node 4. You have to choose one of the color from this given 3 color, such that 2 adjacent nodes should not have the same color. So here, this may be treated as X1, X2, X3, X4. X1 can choose any value from these 3 color. So agent A1 is deployed here in this node. Agent A1 is responsible for choosing any of these 3 color, for X1. Agent A2 is responsible for choosing the color of X2 from any of these 3 color. Similarly for this, similarly for this. If this is a combination, so this can be called as a valid color because no 2 adjacent nodes have the same color. No 2 adjacent nodes have the same color. But here it is not a valid color. 2 adjacent nodes have a same color. Now if you go for constant satisfaction problem, then this allocation is not possible. This is a violation. All right. this is possible. If you go for constant optimization problem, then if there is this type of combination, then the payoff will be degraded. The payoff will be degraded. That means there will be some kind of negative value. If it is a constant satisfaction problem, there is no optimization kind of thing. You have to abide by the constraint. If it is a constant optimization problem, then if there is any conflict, or if there is any violation of the constraint, should have a negative value. So initially there is no color. All are given some kind of negative value. If these two nodes have the same color, we'll have a -1. If these two nodes have the same color, we'll have -2. These two same color, -3. These two same color, -1. So here the allocation is perfect. So that's why 0. Here the allocation is these two node has the conflicting color. So it hold -2. So this is called constant satisfaction. This is constant optimization problem. Okay. Now the question is, as I said, that for each node there is an individual agent. Agent A1 is responsible for choosing any of these three colors for this node. Agent A2 is responsible for choosing any of these three colors for this node. Agent A3 is responsible for choosing any of these three colors for this node. Agent A4 is responsible for choosing any of these three colors for this node. So whenever A3 chooses a particular color, it needs to be communicated to its local neighbor. Only the agent can communicate with its neighbor that I have chosen this color. So accordingly, A1 will choose something and will communicate its neighbor. So this way it goes on. Okay. So some of the example for this typical graph coloring classical problem is meeting scheduling problem, where people have given their preferences of time slot, and you have to choose a common time slot where everybody is available. And most of the people's preferences are satisfied. Somebody has given the preferences as 12. Somebody has given the 12. Somebody has given from here. Somebody has given from here. So now you have to choose which one will satisfy all the constraints. Okay. So objective is to find a valid schedule for the meeting while maximizing the sum of the individual's preferences. Sum of the individual's preferences. A set of agents representing participants, a set of variables representing meeting starting time according to the participant. Hard constraint. So there can be hard constraint, there can be soft constraint, as I said. Hard constraint, starting meeting times across different agents are equal. That means everybody should attend the meeting, nobody should miss. Meeting for the same agent are non-overlapping. That means two meetings for the same person should not have the same time. Soft constraint represent agents' preferences. Normally, I don't prefer to have meeting in the evening, because in the evening I have some other work with the community. So that is my preferences. But if there is a requirement, I can be available. So that is a soft constraint. Okay. So this is one of the area where the research is going on, typically on agent multi-agent system, where you have the use of algorithms, distributed algorithms, and agent technology is there. So there are a lot of other applications where you have sensor network, use of sensor network, target tracking, you have meeting scheduling problem, coalition formations in supply chain management. There are a lot of applications where people are working. in this domain. So some of my PhDs who completed there are some are already completed, are already going on. So they worked on these areas where agent and multi-agent system have been used a lot. Okay, so thank you.
So thank you, sir. Thank you for your valuable session.
If you have any questions, I can be.
If anyone has any question, please ask, sir.
No, sir.
No, sir. Okay.
Okay, sir. I think there is no question. So we would like to wrap up the session. And great, thank you, everyone. We appreciate you being here. Thanks again for joining us today, and we'll see you next time. Thank you for every participants, and thank you, sir.
Thank you so much.
Thank you, sir.
Thank you, thank you.
Thank you so much.
Thank you, sir.
Thank you. Thank you so much. Thank you. Okay, then bye.
Okay. Yes, sir. Okay. So we are ending the session.
Okay, sir.